Hi everyone. So welcome to the video. Today we will be talking about the TwoSum problem, which is a very good starting point for the DSA. And you can say this is the hello world of data structures and algorithm. So let's get started. So we'll start with the problem statement first. So the problem statement says, given an array nums of integers and a target value, right? And we need to find a pair which leads the sum up to the target, right? And there is an assumption given that each input would have exactly one solution and you may not use the same element twice. All right. So let's just see the example first. So we have an array which is given 2, 7, 11, 15 and the target value is 9. So by seeing this, we can say the answer will be 0 and 1 because 2 and 7 leads to 9. Similarly, in the second example, we see that it's given 3, 2, 4 and the target is 6. So the answer would be 1 and 2, which because 2 and 4 leads to 6. How to approach a problem? So by just seeing the problem, and if you are not able to understand the problem, first thing you should do, you should try and read the problem twice. Okay, then it will be a little bit more clear. Then try to see the examples to just make sense out of the problem. After that, think about the most brute force solution to solve the problem. Don't think about the optimization first. Think about the brute force solution. Okay. So how should we think about brute force solution here? So for example, this is the example given in which the target is 9. So what we need to do, we need to find a pair, right? In order to find a pair, what we need to do, we need to choose one element out of this array and scan rest of the array with correspond to this element to find the second element which leads the sum to the target value. Okay, so we can say that in order to do this solution, we need to run two nested loops. Okay, one will be I from 0 to n. Inside that there will be another loop which will be j from I plus 1 to n. And if we find that pair, right, basically nums of j is equal to the target, we can say that we have found the solution. We can return the pair now. Okay, so it's a fine solution. It will work, right? But the problem with this that the time complexity becomes order of n square because we are running the nested loops. Okay, so if as soon the input will start growing, we will start seeing the time complexity issues with this solution. So now let's think about how we can optimize this now. Okay, so in order to optimize this, look at the brute force solution where the extra time is going, and we can see that this is the piece which is causing this extra time, right? So how we can optimize this? Okay, so just to look at the problem in a different way, we can say what is the problem is asking, x plus y is equal to the target, right? And if we can modify the equation a little bit, then we can say x is equal to target minus y, right? So what we can say here, like if we compute this part of the equation, target minus some element, and the resultant should be part of the array in order to achieve this, find the pair, right? And if we can find this element inside my array, then we can say that we have found a pair, right? And if we do just the normal lookup in the array, it's again going to be order of n square. So we need to find some data structure in which we can do a order of 1 lookup, right? So what data structure we have? We have hash map, which can be used for order of 1 lookup, right? So now what we can do is inside my loop, first we need to fill my hash map with the array elements. Then what we can do inside my first loop, we'll evaluate this equation. Okay, and the result we are trying to find in my hash map because we have already filled it with the array, and that lookup will be order of 1. And if we find the value, okay, and the index is not equal to the current index which is running in the loop, then we can say we have found a pair and we can just return that. Okay, that way we will be able to optimize this, and now the time complexity would become order of n, and my space complexity would also become order of n because we are creating a hash map which is going to take extra space. So we can see, like, after taking some space, extra space, we are able to reduce the significant time complexity. So that is a trade-off here, but I think we are able to optimize it to the linear time, which is very good. So yep, I think that is the solution. You can try this solution. I'll share the link. You can try and practice the problem, and if you have any questions, just let me know. Then I'll see you in the next video. Thank you.